Hi, welcome to Chapter 4 Solutions. Just give me 1 second. I'm signing up for my GRE. That reminds me, have you signed up yet? You need to give yourself a lot of lead time because slots fill up quickly, and you don't want to have to drive all the way to Iowa to take your test. Okay, we're going to go ahead and get started with number 1. Since I have my computer here, I'm going to go ahead and read it. It says if Carol spent $22 on 7 knickknacks, and the average of 4 of the knickknacks was $3.50, what was the approximate average cost of the remaining knickknacks? Okay, so we are looking for the average cost of the remaining knickknacks. So there are 3 knickknacks remaining. So we want the average of the remaining 3. Let's keep that in mind. Let's also keep in mind our formulas. So in order to find the average, we need the sum of our items divided by the number of items that we have. I've also rewritten that formula by multiplying both sides of the equation by the number of items that we have. Because a lot of times when we have an average problem, we forget that we need the sum. So for example, in order to find the sum of our remaining 3 knickknacks, the average of the remaining 3, we need to know the sum of the 3 divided by 3, and that will give us the average. So we first have to find the sum of our 3 knickknacks. So to find the sum of our 3 knickknacks, we take the total sum, which is the $22 that Carol spent, minus the sum of the 4 knickknacks, and that will give us the sum of the remaining 3. Well, the sum of the 4 knickknacks is the average that she spent, $3.50, times the 4 items. So this sum sub 4 is $3.50 times 4, which is $14. And so that means that the cost of the remaining 3 knickknacks is $8. So if the sum is $8 and we have 3 items, we just put it into our formula. So the sum of the 3 items divided by 3 is 8 divided by 3, and to the nearest penny, that's $2.67 on average for the remaining 3 knickknacks. Number 2, we're told that last week the average temperature was 88 degrees. And the 3 days that followed had an average of 92 degrees. And we're asked to find the average temperature over that 10-day period. So when we're told last week, we can be confident that they are referring to a full 7 days because they are asking us specifically about a 10-day period. So to find the average, we add up our numbers and divide by the number of numbers that we have. Be careful not to simply add 88 and 92 and take the average of that, because the 88 counts more than the 92 does, because the 88 is over a 7-day period, so that has more weight than the 92 degrees over the 3-day period. So this is a weighted average. To do a weighted average, we take our number times our weight, which in this case is 7 days, plus our next number times the weight, which is 3 days, and divide by the sum of the weights. Okay, so this is a weighted average. One thing that you could do here is, if you're having trouble envisioning this 88 degrees counts 7 times. So it's like adding 88 7 times here and adding 92 3 times. And then you can envision that you have 10 numbers up here, which is why we're dividing by a total of 10. So I'm going to go ahead and calculate this. 88 times 7 is 616, plus 92 times 3 is 276 divided by 10. And we end up getting 892 over 10, which is 89.2 degrees on average. Okay, so the answer choice is B. If you think about it, this makes a lot of sense. If you go back over to the original numbers that they gave us, 88 and 92, the average of 88 and 92 is 90. So if it was 88 degrees for the same number of days as it was 92 degrees, then the average would be 90. However, the average has to be weighted toward the 88, so it has to be less than 90. Okay? If we had more days that went into the average of 92 degrees, the average would have to be more than 90. So you know that your 89.2 makes sense. So always do a little check like that whenever possible. Number three, we're told that Elgin sold 5 paintings, and we know the average of 3 of the paintings he sold, and then the average of the other 2 paintings that he sold, and we're asked simply to find the total amount of money that Elgin grossed for these 5 paintings. So, if you recall, this form of the average formula, where the sum is equal to the average times the number of numbers, I simply plugged in the relevant numbers for the first 3 paintings and for the second 2 paintings. So the amount he grossed, or the sum of the first 3 paintings, is the average, which we're told is $495, times the number of paintings that went into the average, which is 3. So 495 times 3 is $1,485. So he grossed $1,485 for the first 3 paintings. For the other 2 paintings, they sold at an average of $895 each. So the average times the number of numbers is $895 times 2, which is $1,790. And then the total that he grossed would be the sum of these 2 numbers, which is $3,275. So he grossed $3,275, and you have to type that into the solution box. Number 4, we're asked to find the average speed of a motorcyclist who was riding for 5 hours. The motorcyclist rode for 1 hour at 40 miles per hour while in the city, and then for 80 miles per hour for the next 4 hours while on the highway. So the formula to find the average speed is just a variation of the regular average formula. So you need the sum, or the total number of miles, which in this case is the total distance, divided by how long you were driving, the number of hours or the total time. So in this case, the total distance is going to be the 40 miles times 1 hour plus the 80 miles times 4 hours. So in the first hour, the motorcyclist rode 40 miles, and then the next 4 hours, the motorcyclist went 320 miles. 80 miles per hour for 4 hours, divided by the total riding time, which is 5. So you can consider these to be weights, similar to the weighted average problem that we just did. So the 80 counts 4 times as much in the average as the 40 does, because the motorcyclist was riding at 80 for 4 times as long as at 40. Okay, so this is just 40 plus 320, which is 360, divided by 5. So the motorcyclist's average speed was 72 miles per hour. So the answer is D. Number 5. For number 5, we're asked for the mean of the median and mode of these numbers. So here, you're just being tested to make sure you understand how to calculate the median, the mean, and the mode. Okay? So to find the median, you need to make sure that your numbers are in ascending order. So that would be 1, 5, 9, 10, 12, 16, 16. So the median is just your number in the middle, so that would be 10. So your median is 10, and your mode is your number that is listed the most, which is 16. And then we're asked to find the mean of these 2 numbers. So mean is the sum of our numbers divided by our number of numbers. So we have 26 divided by 2, which is 13, and our answer is 13, and you would put that in the solution box. Number 6. For number 6, we're given a list of numbers similar to number 5, only in this case we have 2 unknowns in our list. And we are asked to find the average of those unknowns. So remember, it's very helpful to write down what you're being asked so you can keep that in mind as you work through the problem. So this means that we need to know what x and y are so that we can divide it by 2. Or at a minimum, we need to know what the sum of x and y is. Okay, so we are told that y is less than x, and both of which are less than 5, and that our modes are 3 and 8. So why is this useful? Our modes are 3 and 8, so that means the number listed the most is listed 2 times. Because if 8 is a mode and 3 is a mode, we have to have 2 3s. So that means automatically that either x or y is 3. Okay? So let's test out the 2 scenarios. let x equal 3. If x equals 3, and we know that y is less than x, then y has to equal 2. The reason y has to equal 2 is because it cannot equal 1. Y is less than x. However, if y equaled 1, then we would have another mode. And the only modes are 8 and 3. Okay? So if x is 3, then y has to be 2. But the other case is that it's possible that y could be 3. So if y is 3, then x would have to be 4. Because if y is 3, x has to be more, so x could be 4, and x cannot go above 4 because it has to be less than 5, and it is an integer. So we are asked for what the average could be, so we have to take the average of this set of numbers and the average of this set of numbers. So the first average is simply 3 plus 2 divided by 2, which is 2.5. And the second average is 3 plus 4 divided by 2, which is 3.5. So we have two answers here, and you have to include both in order to get the answer correct. So the answer choices are B and D for this one. Number 7. Number 7 is a quantitative comparison question, and we're asked to find which is greater, the mean of column A or the mean of column B. So you might notice right off the bat that the sum of the two columns, the sums are actually equal, because although this one has an extra number, the extra number is 0. So that does come into play in this question. So remember that the average is simply the sum divided by the number of numbers that we have. So here the sum is 10 plus x divided by 3 to get the average, versus this, which is 10 plus x divided by 4. So depending on the question, this could actually be enough information to tell us that quantity A is larger, but the answer is actually going to be D for a few different reasons. So, for example, let's say that x is negative 10. If x is negative 10, then this numerator is going to be 0, and 0 divided by 3 is the same as 0 divided by 4. So the two answers could be the same. Now, let's say that x is, say, 5. If x is 5, this column is going to be 15 divided by 3. So it's going to give us 5, versus this column is going to be 15 divided by 4, which I believe is 3.75. So column A is bigger. Now let's say that this is negative 20. So if x is negative, we might get a different result. So if x is negative 20 plus 10 is negative 10 divided by 3, which is negative 3 1/3, versus putting in the negative 20 over here. 10 plus 20 is negative 20 divided by, 10 plus negative 20 is negative 10 divided by 4, which is negative 2.5. So this number is actually bigger when x results in a negative fraction, and over here when x produces a positive fraction, column A is bigger. So you can get A is bigger, B is bigger, or that they are the same. So the answer is D. Number 8 is a similar problem to number 7. Again, it's a quantitative comparison, and we're asked to compare the mean of these three numbers to the mean of these three numbers. So again, we need to find the sum and divide by the number of numbers. So this sum is 12 plus x divided by 3. And this sum is also 12 plus x. Okay, the difference between this problem and the last problem is that we are dividing by 3 for quantity A and for quantity B. Therefore, the answer is C, because no matter what x is, you will get the same result here as you will get here, because we have 3 numbers here and 3 numbers here. So you might say, is this really 4 numbers? But a comma indicates a separation of numbers. So this x plus 2 only counts as 1 number, so that's why we're dividing by 3. Answer choice C. Number 9. Number 9 asked us to find the average of these three numbers. And the reason we know that it's three numbers, again, is because there's a comma separating each term. So don't get intimidated by this. If you look at the answer choices, you'll see that the variables are still in the answer choices. So we're simply adding these we're adding these three terms up and dividing by 3. So when you add these terms up, you need to make sure to combine like terms and then simply divide by 3. So we have one term with m in it, one term with n, and one term with p. So the 3m, 6n, and 9p cannot be combined. So we'll just put those down there. Then we have a +3, a -2, and a +6. So those numbers can be combined. So 3 minus 2 is 1, plus 6 gives us 7. And then we're going to go through and divide this by 3. So you might think, fantastic, we're done. But if you look at the answer choices, none of them look like this. Okay, they're similar but not quite like this. So actually the answer choices go through and divide each one of these terms by 3. So remember, you cannot simply cross out this 3 with this 3. Every single term here has to be divided by 3. So 3m divided by 3 is just m. 6n divided by 3, 6 divided by 3 gives us 2. So 6n divided by 3 is 2n, plus 9p divided by 3, which is 3p, and finally plus 7 over 3. So the answer choice is B. Number 10. So we're told that Sean drives X miles at 40 miles per hour and Y miles at 60 miles per hour, and we are asked for his average speed. So we had an average speed question earlier in this practice set. So again, that's just the total distance divided by the total time. The difference here is that we have variables which complicate things a bit. The numerator, though, is simple. Sean went X miles at 40 miles per hour and then an additional Y miles when he was going 60 miles per hour. So our numerator is simply X plus Y for the total distance. The challenge then is the time. So he went X miles per hour for, he went X miles at 40 miles per hour. So we have to use this information to express the time that Sean traveled. So what I like to do in cases like this is temporarily plug in a number to make the problem easier to grasp. So let's say that he went 80 miles at 40 miles per hour. How long would this have taken him? So this question becomes much simpler. If you're going 45 miles per hour, you go 80 miles, it took you 2 hours. So you have to figure out what is the operation that you have to do here. Well, 80 divided by the 40 gives you 2. Gives you the 2 hours, and that's the time. So the same thing here. X divided by 40 tells you how long Sean was traveling at 40 miles per hour. Okay, so temporarily plug in a number and see what the operation is, and then go back to the original expression. So the time going at 40 miles per hour is X over 40, and by the same token, the time going at 60 miles per hour is Y over 60. So this is our average speed. Terrific. But then you look and say, the book doesn't have it like that as an answer choice. So what can we do? We can simplify this denominator here. If we simplify the denominator, we need a common denominator. So a common multiple of 40 and 60 is 120. So if I multiply the top and bottom by 3 here, I get a denominator of 120. And if I multiply the top and bottom by 2 here, I get 120. So my denominator becomes 3x over 120 and 2y over 120. And my numerator is still x plus y. Okay, now, shifting over, I can simplify this denominator because I have a common denominator. So it's now 3x plus 2y divided by 120 and x plus y in the numerator. Now, this should be getting familiar to you at this point. If you're dividing by a fraction, that's the same as multiplying by the reciprocal. So we simply flip this fraction over and we get x plus y times 120 over 3x plus 2y. This x plus y, this original x plus y, we can put over 1 and then simply multiply across. So that would be 120 times the quantity x plus y over 3x plus 2y, and thankfully that is the end of the problem because we have run out of space. Okay, so it's 120 times the quantity x plus y divided by 3x plus 2y, and that is answer choice D. Number 11. Number 11 tells us that the class average is 58 and that Stephen's score is between 1 and 2 standard deviations below the mean. So if the class mean is 58 and 1 standard deviation is 6, to get within 1 standard deviation of the class mean, it's either plus or minus 6 to this number. If you get 1 standard deviation above, it's plus 6, and 1 standard deviation below, it's minus 6. Okay? So to be within 1 standard deviation of 58, you have to be between 52 and 64. That's being within 1 standard deviation. Okay? In this particular question, we're told that Stephen is between 1 and 2 standard deviations below. So we don't actually have to consider the above part, but I just wanted to show you what that would look like to be within 1 standard deviation. You'd have to be in between 52 and 64. So let's first calculate 1 standard deviation below, which means we just subtract 6 from the average. So 52 is 1 standard deviation below. And to be 2 standard deviations below, we have to subtract 6 twice, or 2 times 6. So we have to take off 12, which means that Stephen could have gotten 58 minus 12, or 46. So he could have gotten anywhere between a 46 and a 52, including 46 or 52. So the answer choices that work are B and C, because B says he could have gotten a 48 and C says he could have gotten a 52. That wraps up Chapter 4 solutions. Make sure you go ahead and do the problems in the official guide that are associated with this chapter, and we will see you back for Chapter 5. Good luck!